Okay. All right, thanks, Ben. So today's presentation is on an all-electric home renovation in Detroit. And I'm going to just move into the main slide here. So myself, Chris McTaggart, and Nick and Brian are here to co-present with me. So this is a project that is personal to me. This is I'm the homeowner and acted as the general contractor on this project. And we thought that this would be a really important presentation to do, especially with this group and especially following last month's discussion on home repair programs and energy efficiency in the city. So I'm just going to briefly introduce myself for those of you who don't know me. And Chris McTaggart and I co-presented on this at the Detroit Sustainable Forum in September. And I felt like this was a more appropriate headshot for this presentation. This was one of the dirtiest jobs I had to do on this project. But just a little bit about myself. I mentioned I am a program manager with the Detroit 2030 district. I have a background in architecture and design build, so I've always been interested in doing projects like this. I'm the board president of the Great Lakes Renewable Energy Association and co-chair this committee, the EWR committee of the Detroit City Council Green Task Force, and I'm also a resident of District 7 in Detroit. And I wanted to have each of our other contractors introduce themselves as well. Chris?
A good watch. Okay, just don't go.
Yeah, thanks, Kendall. So I'm Chris McTaggart. I own a energy efficiency consulting business here based in the city of Detroit called Dream Development and Energy Technology, aka Dream DET. I mainly focus on higher end energy efficiency goals for homeowners. So new construction projects pursuing things like passive house or net zero. Okay. But then also, Kendall's project really appealed to me because she was attempting to basically achieve, close to a near net zero without adding any solar panels for an all-electric type of home. So definitely excited to co-present along with Kendall today.
Thanks, Chris. And then I also wanted Brian and Nick to introduce themselves.
Yeah, so we own Great Lakes Building Innovations. We're a small contractor in northern Oakland County that specializes in air sealing. We own the aero barrier business here for the state of Michigan, and air sealing is an integral part of helping make any home not only more comfortable, but more energy efficient. So it's one of the technologies that Kendall used during this remodel, and we're here to talk about it today and answer any questions. Thank you.
Thanks, Nick. Yeah, and I just wanted to mention how incredibly helpful Chris and Nick were on this project with me. I don't think I could have done it without the two of them. And they were many times advisors to me as well. So we're excited to present this project and kind of go through some of the details. Like I said, I'd love for this to be more interactive. So if there are questions, feel free to raise your hand, come off mute and ask, or put it in the chat. I can't see the chat very well, so if somebody does ask a question, maybe Ben or somebody can interrupt me, and we can ask. So to get started, Chris, like I said, we co-presented at the Sustainable Detroit Forum. We only had 10 or 15 minutes to present, so we wanted to do this to the EWR committee so we could take a breath and get into a little bit more specifics about the project and all the reasons why behind it. So I'm going to hand the mic back over to Chris.
Yeah, so, thanks, Kendall. This slide, it looks like it's something out of the early 2000s. And it's kind of done intentionally to get us all thinking in our own heads about what is sustainability. And you know what? I just typed into Google sustainability and then clicked on images, and these are the top 4 images that came up. What does this tell us about what sustainability is? Well, it doesn't tell us anything at all. These are just a bunch of goofy stock images that are meant to represent goals of sustainability. And so some of us on this call, maybe we think like along the lines of these images, green stuff, handprints, things that look like leaves, et cetera, et cetera. Here's the thing, when it really comes down to it, when we talk about sustainability, and particularly in the context of the city of Detroit, there's a lot of different things that could go into influencing sustainability here in the city of Detroit. If any of you all participated in the process of developing the city's sustainability action agenda that was published a handful of years ago, you all might know that there were a series of community meetings that were held that really tried to probe what does this term sustainability mean in the context of the city of Detroit. And so, we could be talking about, when we talk about sustainability in Detroit, we could be talking about, things like economic sustainability, the sustainability of communities working together and having safe communities. We could talk about having clean communities, meaning less garbage or air pollution. We could talk about things like water efficiency or reducing flooding. These are all valid things to think about when it comes to sustainability in the city of Detroit. That said, one of the things that came out of that sustainability action agenda as a key and critical item for what was on the mind of Detroiters was issues of energy efficiency, utility burden. Basically, the amount of energy that all of our homes and businesses use that then translate into dollars that we have to spend. And this would be gas, electricity, water, etc. This causes a significant amount of burden on the average Detroiter. And then, Kendall, if you want to just slide back a couple slides, so those utilities that we think of most in terms of where they hit our pocketbook, the utilities are generated primarily through non-renewable fossil fuel resources that end up contributing to air pollution, water pollution, as well as greenhouse gas emissions, which impact the climate. When we think about, energy related issues, the US is, disproportionately based off our population, a huge consumer of energy. And when you think about where does all this energy get used, buildings are actually the number one sector, more than the factories that are producing, cars and trucks and, consumer goods and all the rest like that, more than transportation, so all of our cars driving around and trains and planes and buses, all of the energy that goes into transportation is ultimately contributes to less of the energy burden of this country than buildings. And, I think it's easy to look at skyscrapers and big warehouses and go, well, those must be the buildings that really use the most energy. But no, ultimately, residential buildings in this country use more energy than commercial buildings. So this is why I've really kind of focused my career on residential energy efficiency, because it is a very significant source of energy used and waste, and as well as a contributor to pollution issues associated with burning fossil fuels. It also ends up affecting consumers most directly. More, ultimately we pay for all these things, so like, the cost of energy waste and transportation, you know, we see it in our grocery prices. We see it in our consumer good prices. You know, the cost of energy and industrial, again, we see those in prices of consumer goods and things like that. But, you know, the bills that we pay at our home, these are things that affect us immediately and directly. And they're things that are controllable. You know, maybe go to the next slide. You know, and so when we talk about, well, what can we do about this situation? You know, and you know, a lot of people's minds initially go to things like, well, solar panels, that's the solution. We're going to produce more energy at our homes. And I am an advocate for on-site power production using solar or wind or things like that. But realistically speaking, that's like the last thing that you do. The first thing that we need to think about are things that save energy. Energy efficiency upgrades. And energy efficiency, think about it a little bit differently than energy conservation. Energy conservation is like put on an extra sweater in the winter and turn down your thermostat in your home. That's energy conservation. That means you're choosing to use less energy. And that's great if you want to make those choices. But, you know, when we're talking about ways to really impact, you know, U.S. emissions from the building sector, we have to start thinking about things that are approachable to the average person. And the average person isn't necessarily going to forego creature comforts in order to be more green or be more sustainable. They're going to want the product to just work better. That's what energy efficiency is about. It is about improving buildings, making them more resilient, more well insulative, more well draft sealed, with better mechanical systems, better lighting and appliance systems, so that ultimately the homes use less energy, despite the fact that they function just as well, if not better, than any other home. You know, the other kind of benefit of energy efficiency, aside from saving money and saving energy waste from occurring, is that energy efficient homes tend to be more comfortable. When you add insulation to buildings and you make buildings more draft sealed, they're more comfortable because we don't have uncontrolled airflow coming in and out of the home. We don't have temperature swings that go from, you know, room to room in the home. They tend to be more durable homes. You know, when you've got really leaky home that's not well insulated, you know, there's the potential risk of mold and rot, of insects coming into the building, causing decay, you know, and insulated buildings tend to be, they tend to have less noise. So, you know, if you're in the middle of the city, you know, and you want a peaceful indoor environment to live, when you seal up a home well and you insulate it well, you tend to have less exterior noise coming from the outside of your home entering the home. So there's a lot of other sort of intangibles that come as benefits with energy efficient homes. Go ahead, Kendall. You know, again, you know, just to touch on what I already did, you know, the city of Detroit released a sustainability action agenda that, you know, came about through, you know, sort of a community engagement process, and utility burden was one of the main things that needed to be addressed. And frankly speaking, I still think that this is an issue that, you know, the city really needs to figure out more of an approach to really crack the nut here, because it's a huge issue. The average, you know, age of buildings in the city of Detroit is probably something like, you know, 1940s or something like that. There's vast swaths of the city of Detroit that have aging building stock that were built before insulation was a standard feature of construction. I can speak from my own experience. When I bought my home in the north side of Detroit, 1927 home, it had no insulation anywhere in the building. So no attic insulation, no wall insulation, no basement wall insulation, nothing, you know, and all original windows. And so my house was very cold and uncomfortable when I first moved into it. And we had higher energy bills in, you know, the first year of ownership, because, you know, basically I had a drafty, old, unsealed, uninsulated building. So, and that's like every single one of my neighbors, just about. And, you know, when you extend it out to the whole city, that's a huge amount of the city that has this type of building stock. And so unless people are, you know, unless we have a consensus plan for how to address this, you know, it's going to be challenging because it's a big issue. You know, sometimes the things that we might want to do to homes to improve their efficiency, like weatherization, adding insulation, draft sealing buildings, etc. You know, if you've got, you know, other durability related issues, you know, a leaky roof, you know, or, you know, gutters or foundation issues, sometimes insulation and air sealing, you know, have to wait until that, you know, after those things. So, you know, I know there was a presentation last week, month that talked more about kind of, you know, that combined solution that we need, but we can keep going here. You know, go ahead, Kendall, I guess that's you.
Yeah, thanks, Chris, for kind of opening up the presentation with some of that background.
Hi, Jill. This is Carrie Harkness calling.
Oh.
How are you?
Carrie.
Good, but frustrated.
And Chris, are you
So-
I
able?
gotcha.
Mute?
No, that's okay. Well,
Come
I'm not
on.
sure I'm
How
doing
fast
it
can I get to
correctly.
it? All right, go ahead, Kendall.
Okay, thank you. So just wanted to start, talking about the house and the project, just where it's located. So I don't know how many people are familiar with the Warrendale neighborhood in Detroit, but I just wanted to share a little bit about it. I had picked up some of these clips of description from some recent news articles about Warrendale, but it's one of Detroit's largest working class, most affordable, unpretentious neighborhoods surrounded by suburbs, surrounded on all three sides by Dearborn and Dearborn Heights. It's just a few blocks from Rouge Park, which is the largest public park in Detroit. It has the highest density of Detroit's child population, and it is one of the city's strategic neighborhood fund areas. And the plan is going to be centered around children. So just a little bit about where the neighborhood is in the city. Let me go to the next slide here. So why this project? I just wanted to give a little bit of background about myself, why I wanted to pursue this project. Ever since I was a young person, I had a passion to renovate homes and buildings in Detroit. And that's sort of what led me to pursue a degree in architecture and design build. I was very interested in my family history, my roots being in Detroit. And so when this home became available through the land bank auction, this was a former family home that my great-grandparents had lived in. So I saw this as an opportunity. I also have a lot of interest in investing, whether it's financially or any way, but investing in the community, investing in ways to improve the community. And this is one way that I wanted to do that in this neighborhood. Obviously, we talk about a lot of these issues in the EWR committee around health, well-being, and comfort of building and home occupants. We talk about utility costs. So from a professional and personal standpoint, it was important to me to be a part of redeveloping a property, especially affordable rental housing that does prioritize health, well-being, and comfort of occupants, that does consider having low to no utility costs, and then also considers the environment through energy efficiency and other design choices. So in addition to all of that, I have a lot of deep concern about climate change and resiliency of our city and the residents in Detroit. And so I wanted to try to take all of this and contribute to a solution through this project, through this one house. And then I also had a lot of personal interest in learning directly from, having direct project experience. So as the homeowner and the general contractor on this project, I gained a lot of valuable experience and wanted to present some of what I learned and some of the mistakes along the way, thinking that might be helpful for this audience as well. So just briefly, and thank you for letting me share about my personal story here. but I had two great grandparents that immigrated separately from one from Ukraine and one from Russia, and they met in the U.S. and they were married. They lived in Southwest Detroit. The photo on the right shows them with their three children, the fourth one yet to be born, which is my grandmother. She's 91 years old today. When she was 14 years old, they moved to the west side of Detroit, and they moved into the home that I purchased from the land bank in one of the auctions for starting bid of $1,000. Also a fun little story with the little hearts here. The heart in the top left corner, that is the house that I renovated, where my grandmother grew up as a teenager. The house in the bottom right is where my husband and I currently live. And then the house in the middle, that home belonged to my other set of great grandparents. So when my grandparents were growing up, they met, having lived one street over from each other. So fun family history. This is my grandparents and their three children. When they were married, they lived in the house that I renovated and had their first two children before they moved to the suburbs. So this is a before and after photo of the house. This is a Google Street View image before the land bank had it may have been before or after the land bank acquired it. Looks like it was before the door was wide open. So I just wanted to show you what I was starting with and where I currently am with this home. So what we're going to try to go through with this presentation today is talk about how this home achieved a HERS score of 40. And so for those that aren't familiar, HERS stands for Home Energy Rating System. And this is the industry standard on how a home's energy efficiency is measured. So the lower the score, it means it's more energy efficient. Chris, feel free to chime in here because I know you had pulled together a lot of this information, but
yeah, so
yeah.
Just to kind of better understand, so Kendall, when she approached me and said that she's doing this deep energy retrofit on this family home of hers, the timing ended up being perfect that there was a utility incentive program that was targeting all electric homes. And so there was the ability to be able to tap into some of these utility incentive dollars to help support Kendall's ambition to take this home to an all electric near net zero type of an approach. And so the way that the program works is it's a performance-based program that uses the Home Energy Rating System, or the HERS system. And the way that HERS works, it's the main national system that we have for basically depicting the energy efficiency of a home. And so the lower the HERS score, the better. So there is a reference design case that is used to that all homes are compared to, that basically is like a brand new federal minimum home from 2006. So a home from 15-20 years ago, basically, with whatever the energy code insulation values and air tightness values and mechanical system values were from that point. So that reference home gets a HERS index of 100. For every percent energy savings of the actual home or the rated home compared to that reference home is a 1-point reduction in the HERS index. So for the program, they were targeting homes that were achieving a HERS index of 40 before any on-site power production. So HERS index of 40 without any solar panels on the house. So that would be a home that's 60% more efficient than the HERS reference home. And just for context, the average HERS index score in 2021 in Michigan was a HERS 57. So those are all brand new homes being built. So this was, this is a home from the 20s, basically getting renovated down to a HERS index of of 40. That's a very significant improvement. Most likely the home in as is condition before Kendall did anything to it would have scored well above 100, probably somewhere in the 150, maybe even close to a 200 on the HERS index range. So that's kind of how the HERS index works. This is why the utilities use that as a reference for kind of a starting point for participating in its program.
Thanks, Chris. So again, this is the condition of the home. When this is actually prior to the land bank acquiring and auctioning the home. Just wanted to give you an idea of what it looked like and where I was starting from. So I have a lot of photos that I'm going to go through, but just the house was full of furniture, trash, wide open to the elements, doors, windows, no doors, windows, the kitchen, some water damage where there were two places where the roof had rotted through, so there was some water damage, fairly minimal, but still significant. And this is what the front of the house looked like and the back of the house on the day that the land bank was doing an open house, which if you're not familiar, when they do these auctions, they sometimes or often have open houses so you can do a quick walkthrough prior to the auction. So that was the actual day that I saw the house. This was, I'll just share, this was not planned. I happened to open a land bank open house email and just kind of skimmed it. And I noticed the address and I called my grandma just to confirm, like, is this your old house? And when I saw that, I made a quick decision that I wanted to purchase this home. So this is just, these are very basic layout, but it shows you the first floor and the second floor. There's two front living rooms / dining rooms. So there's two main areas, common spaces. And the first floor, there's 2 bedrooms, a bathroom and kitchen. The second floor, there's 1 bedroom, a bathroom and kitchen. So this house was built in 1925 as a single family home. But when the home in 1937, the homeowner had pulled a permit with the city of Detroit to turn this into a 2-family. So it's a unique home in that sense too. So when my family moved in, this was a 2-family home. And that's why when my grandparents got married, they started off by living in one of the units while a family member lived in the other. So as you're all familiar, finding financing for these projects is challenging. And when I purchased the home, my plan was to pursue the Detroit Home Mortgage Program, which would provide me all of the funds to do the full renovation. And this would also help me meet the land bank's requirements of renovating the home within 6 months. So I was moving forward with that. And we got to a point where that we realized that was not going to be an option for my project because of home appraisals in this neighborhood being so low. So I needed to find other ways to finance certain elements of the project so that I could go back to the home mortgage program to get the remaining, which that didn't end up happening. But either way, Michigan Saves was really helpful. They helped me with the very first improvement on this house, which was the roof. And I made the big decision to go with a metal roof because the metal roof will last nearly forever. It shouldn't have to be replaced. The contractor I worked with became a Michigan Saves contractor. I was able to finance, and that was a helpful way to kick this project off by making sure that the home was dry. So my intention with this project was always to renovate all electric and for it to be highly energy efficient home. I didn't exactly know how I was going to get there, especially having to piece together financing. Then a colleague who I think is in the audience had shared this pilot program with me. DTE launched an all electric homes pilot. They had both a market home pilot and an affordable homes pilot. So my project was eligible for this pilot. So this is how Chris and I found each other. He was the HERS rater, the DTE approved HERS rater on my project. And I wanted to just share a little bit about the affordable piece, the affordability incentive eligibility. It was based on qualified census tracts. So the location of the home is in an income qualified census tract. So that is what allowed my project to be eligible for the affordable incentives. Very briefly, these are just some clips from the application. Some of the incentives that were available and some of them that I pursued. Chris can talk a little bit more about this, but there was a lot of back and forth between Chris and I on he built the energy model. Him and I went back and forth on different decisions that I had to make and how they would impact my HERS score and my eligibility to receive the DTE incentives. So lots of back and forth, but these were some of the incentives that I pursued with my project, and we'll go through these more. So I'm going to turn it back to Chris before I go through several photos showing the progress of the house and the project.
Yeah, so, again, this pilot program through the utilities was meant to test the waters for all electric homes in the state of Michigan. The reason why the utilities are interested in this is because, there is a growing consensus that, in order to really transform the residential building sector, and to help it become carbon neutral, we need 100% clean energy production through the utilities. But that's not going to do as well for getting us to our net zero, carbon zero goals if we're still using fossil fuel combustion appliances inside of the home. And honestly, for many years, that meant basically, if you're going to have an all electric home, you had a couple of options. You could do electric resistance heating, which is a very affordable first cost of the equipment for the home, but it means that basically you would be paying a lot in energy bills because electric resistance heating, it's 100% efficient, but electricity is a lot more expensive per unit of heat energy than natural gas. So we measure heat energy in terms of BTUs or British thermal units. So basically, electricity is about 6 to 8 times more expensive per unit of heat energy than natural gas. So that means that, even though electricity is 100% efficient, it's not necessarily, that cost effective. So you need to start using things called heat pumps. Heat pumps are heat exchange electric heating systems that move heat from inside the building to outside, basically through either moving refrigerants to an outdoor compressor unit, or potentially through a ground loop exchange if you had geothermal heating and cooling. So, for many years, it was sort of like, well, if you're going to be in a cold climate and you're going to do, electric heating, you had to go with ground source heat pumps or geothermal heating systems. The challenge is that those are actually pretty expensive to implement because you have to dig wells or trenches in order to implement those. So the first cost of geothermal is actually quite significant. Air source heat pumps, those that use refrigerants to connect to an outdoor compressor unit, are historically thought to be inappropriate for cold climates because they wouldn't operate at very cold temperatures, or their efficiency would be so reduced at cold temperatures that they would be less cost effective to use. Well, in the last decade or two, really, there's been a significant investment in what we refer to as being cold climate heat pumps. Heat pumps that are able to operate at more extreme outdoor temperatures such that they keep their efficiency down to 5 degrees Fahrenheit, and that they can even operate down to minus 13 degrees Fahrenheit and still perform adequately. So this technology, it's not exactly new technology, but I would say that the mindset of working with this technology in the state of Michigan is somewhat new. Most heating contractors in the state of Michigan, HVAC contractors, frankly speaking, they're very used to working on older homes because we have a very old building stock. And so they're used to working on natural gas furnaces and boilers because that's what the vast majority of homes in the state have. So the mindset of using electric heating appliances, cold climate heat pumps, is kind of a new thing. And so the utilities wanted to create a sort of a pilot program to see, what are the actual market barriers, and can we potentially incentivize these homes appropriately so that we can overcome those barriers. So again, this pilot program was based off of the ResNet HERS index. You had to achieve a HERS index score of 40 in order to participate. So again, 60% better than the HERS reference home. There was some allowance for going up to 45 if homes were like really struggling to meet that, but really the utilities pushed to get to HERS 40 basically. And this had to be before adding any on-site power production. So you couldn't use solar panels in order to get to your HERS index score. You had to do this all from efficiency measures. If you want to go to the next slide. So the process for this, again, if you want to have an all electric home, if we're going to electrify homes, what that means is that instead of having a gas furnace, that you would use an electric heat pump instead. And for water heating, you would need to use an electric water heater instead of a gas water heater as well. Standard electric tank water heaters are somewhat costly to operate because, again, just like it is costly to run electric resistance heating because electricity costs 6 times as much as natural gas per BTU, we do the exact same process with heating water. We have to use BTUs of energy in order to heat the water up to 120 degrees Fahrenheit so that, it is an adequate temperature for bathing and cooking and all the other things we use hot water for in homes. So, heat pump water heaters have been on the market probably for about the last decade, and they're starting to become more mainstream. These are electric tank water heaters that have a heat pump on them that basically can exchange heat from inside the building to be able to recover some of that heat and put it into the hot water system. And so instead of them being about 90% efficient, like a standard tank electric water heater would be, these electric heat pump water heaters can be as much as 400% efficient in how they operate. So, definitely using an electric heat pump water heater is a strategy in order to get closer to meeting the program goals. It also means cooking with electricity. So basically our stoves and ovens would be fired by electricity instead of natural gas. And so, the benefit of going about this is, there is no combustion in the home from these sources. There's no heating combustion, no water heating combustion, no cooking combustion. And so there's no risk of combustion pollution entering the home through these sources. Now, that's not to say that any home that uses gas necessarily has dangerous levels of combustion pollution. That's not necessarily the truth. But when we eliminate those sources of potential combustion pollution, then it's just one less thing we have to think about. We don't have to worry about carbon monoxide poisoning or other combustion gases in the home. So that's definitely a benefit. And then the other benefit is that we could offsite the energy used at the building with renewables like solar panels in order to have a net zero home. So theoretically, your home that is all electric, you could add solar panels to the home in order to offset, the entirety of the energy used on site in order to have completely net zero construction. Alternatively, as the utility grid gets more green and incorporates more renewables over time, then the electricity that we use at the home is offset by greener, more renewable energy sources from the utilities. So how does the HERS rating process work? So basically, to produce the HERS index score, a energy modeling program is used. So the utilities have raters use a energy modeling program called Ecotrope. And basically all the energy using features of a home, the building geometry, so the walls and the floors and the attic spaces and the windows are all entered in with their square footages and thermal characteristics. On-site inspections are performed mid-construction to inspect things like air sealing and insulation details. And then at final inspection, performance testing is performed in order to identify things like how airtight is the home, or how tight are the duct systems that convey heating and cooling energy if there are ducts. In the case of Kendall's project, there were no ducts. She had all ductless mini split heat pump systems. But that's essentially how the HERS process works. So again, getting to a 40 or a 45, that'd be much better than the average new construction home. So it's challenging for brand new homes, let alone for homes built in the 1920s. Kendall's home had no insulation. There was a lot of air leakage. This was a drafty old building that was constructed before anybody really cared about energy and environmental related issues. So back in the 1920s, they were not thinking about draft sealing the building, basically. That was not something that was thought about. So, one of the other challenges, not only is it hard to get to a HERS 45, but, I'd say that Kendall and I as well learned some things about, like, if you're going to take on a big project like this that is going to try to achieve something really ambitious, you want to do it holistically. You don't want to try to do it product by product. So Kendall had already selected windows for the home as well as the heat pumps for her home. And don't get me wrong, Kendall made good selections. They were good windows and they were, good heat pumps, but there were more efficient options available on the marketplace that, had she maybe gotten me involved in the process earlier, she may have been able to spend maybe a modest amount additional on those products that may have been able to offset some costs that she had to expend on the home at other points. So like, you see the home right now, and you might notice that there's no siding. That's all just the original building sheathing of the house. And the reason why you don't see any siding is because one of the efficiency measures that Kendall took on was adding new sheathing with insulation, so continuous insulation to the exterior of the walls. And she needed to do that in order to get to the necessary HERS score for the project. That was a big expense that Kendall took on. Now, it had some benefits. she eliminated a source of potential lead paint issues, and likely eliminated the need to ever have to paint or address the cladding on the house in the future, because she put on all brand new vinyl siding. And the house looks real sharp now too. So she did, I'd say future-proof the home in terms of the exterior of it, but it was a big expense that she had to take on. Had we maybe done a little bit more consulting earlier on and chosen some better windows or better heat pumps, she may not have necessarily had to take on that expense. So it's really important that if you're going to take on a big project like this, you want to get with somebody who's more experienced in doing this consulting and energy modeling earlier on in the process. Unfortunately, there's a lot of well-intentioned but somewhat misleading media out there about going green and going all electric, and they just tell people sort of platitudes. Go out there and buy heat pumps. Well, that doesn't tell you very much, because heat pumps come in all different types of efficiencies and configurations. Buy new windows. Well, that doesn't tell you a lot, because windows come in all different types of efficiency ratings too. So, it's really important that before you start spending money on expensive products, windows and heat pumps are expensive no matter what. If you can spend a little bit extra on some of these items from the get-go, it may pay you back by potentially not having to make investments in other areas. Ultimately, one of the big strategies that we used for Kendall's project, which is key to any project that is pursuing a deep energy approach or near net zero approach, is having an airtight building. So when we say airtight building, this is really, think about it more in terms of reducing drafts. All of us know the feeling of being in a drafty building where basically, it's just an uncomfortable space to be in. It feels like cold air is coming in, and so that's what we call a drafty building, or a building that's not airtight. And when we talk about airtight construction, this can be done with a brand new house, through the construction process, using things like caulk and foam and air sealing tapes and things like that. With an existing building, it becomes a lot more difficult. So, again, one thing that Kendall did was she took off her existing siding and she added a sealed air barrier called the Zip system. It's a weather resistive barrier as well as an air barrier product. But then the other big thing she did was a product called Aero Barrier, which is an injectable air sealing product. Basically, think of it like an injectable caulk. And Great Lakes Aero Barrier is going to talk more about that here in just a little bit. Now, once we make a building significantly more airtight, though, we have to also add ventilation. You've probably heard the phrase, a house needs to breathe. That's actually kind of incorrect. Houses are inanimate objects. They do not need to breathe at all. The occupants within homes need fresh air to breathe. And then buildings need to be able to have moisture exchanged. When you have too tight of a building, moisture tends to build up. There's moisture that can come in through vapor through the foundation, or when people cook or take showers in the building. If we're not removing that moisture, then you can have excessive moisture in the building that can cause durability and indoor air quality related issues. So kind of, making a building more draft sealed or air sealed goes hand in hand with then bringing in an efficient ventilation system. So we used an ERV product, or energy recovery ventilator product, for this home in order to make sure that it was well ventilated. For insulation, the exterior walls were dense packed with cellulose insulation. So basically someone drilled holes into the walls and filled it full of insulation. And then again, the Zip system product for the building sheathing was actually an insulated sheathing. So it had some additional R value to it. So her walls are actually very well insulated, even better insulated than I'd say a lot of new construction homes are. She had a well insulated attic, And then finally, heat pump, water heater, all LED lighting, and Energy Star appliances.
So before we move on, I just wanted to go back to your previous slide real quick, Chris, and touch on one point you made about, how you and I met when I had already made some decisions going into this project. I had mentioned this house was purchased from the land bank. The land bank had expectations that homeowners do a full renovation within 6 months. This was during COVID times, but even not during COVID times, that's a really challenging timeline. Also trying to find financing. And so I think where I'm going with this is thinking back to the panel discussion that we had last month with the home repair and energy efficiency programs. One thing we didn't have time to discuss, and I don't know if we will today either, but hopefully in the new year, is with these programs, these programs are addressing certain elements of the home. So how do we get ahead of that in the process if we're thinking about electrifying, or if we're thinking about energy efficiency to this standard? At what point in the process? It has to be designed in the beginning of these projects and in coordination with all of these different programs, in order to kind of get that ultimate energy efficiency that we're all trying to achieve. Something with I think I remember, Chris, something you had mentioned early on. I had purchased the heat pump systems and the windows. The windows I purchased, I had heard somewhere along the line that a window is a window, but you definitely do gain efficiency with triple pane versus double pane. But with my budget and my financing option, I made the decision to go with double pane at the time. With the heat pump system, I think I recall Chris had mentioned at some point I could have gained some efficiency if I had a ducted heat pump system. But in this case, with this home, it previously had radiators, so there was no existing ductwork. So it would have been, it was always balancing efficiency with cost, with and trying to figure out what decision I would make, where that in the energy model, what my HERS score would be. So definitely helpful having somebody. It would be really great to have somebody like Chris or someone advising on these projects from the very beginning, because there's just so many decisions that need to be made. So I just wanted to mention that. And one other thing, we'll get into this later. I want to make sure Nick has time to talk about the aero barrier, but this image here, Chris took this when Nick was out doing the aero barrier. And it has the pre-sealing air infiltration here of 6.10, kind of showing where the house was when they got started with the aero barrier sealing and where we ended. And I just wanted to point this out because this is after emphasizing over and over and over again to every contractor that worked on this project to air seal, air seal, air seal. And even after all of that, where my project still did not meet the requirements for the DTE pilot. But we'll get into that further. This was, some of, Chris has already talked about this. These are several ways in which he provided, he was an advisor to me on this project as the HERS rater. He provided design consulting services. He helped with recommendations on the building enclosure. He talked a little bit about the HERS rating process and the energy modeling. So he came out and he did 2 site visits, which he also talked about. So he did a kind of a pre and a final blower door test to identify air leakage and thermal bridging. So we'll talk a little bit more about that in some future slides. But just Chris was a huge help on this project for me. And one of the big decisions that Chris mentioned that I had to make was how to deal with the existing siding. And I chose these photos because one of my contractors had come out to do a pressure wash of the existing siding, and look at what they did. So, but this was the existing siding. It had at some point been wrapped with aluminum siding that was basically entirely gone by the time I purchased the home. But one of my biggest decisions was, how am I going to address the building enclosure and this existing siding? And ultimately I made that decision to remove that old siding, and then made an even bigger decision to wrap the house with the zip panel. Oh, looks like we're missing an image here, but this is, let me see if I go to another slide. Okay, so early on in the project, made the decision to remove the existing siding, then made the decision to put on the zip panel R6. So it's a 1/2-inch thick plywood and 1-inch thick foam. I think I have that correct. Yes, that was were properly taped. But before we, let me show you here. So this is kind of just a closer up of the zip panel being installed on the home. The photo on the right, I also just wanted to point out because, you know, Nick, I think this is something you had mentioned to me, making sure that this seam where the zip panel meets the brick, the foundation wall, making sure that that's either taped with a proper tape or caulked. And these are little things that the contractor ended up not doing, that I had to make sure I was managing these things carefully and going around and doing these things myself to make sure that they were done. So even though we talked about proper air sealing over and over and over again, we couldn't say it enough, and it's still really required, you know, that the general contractor, myself, to be keeping an eye on all of these little things, and Chris and Nick pointing out things to me along the way as well. So this is just an image of the zip panel being installed. But before the zip panel was installed, just want to go back. So while this crew had torn off the siding, they also had to rebuild a lot of the window boxes because they had seen some severe damage, water damage. Maybe not all of them needed to be replaced, but it was definitely recommended. So I happened to have this crew all to myself. It was February of 2021. Yes. And things were still very uncertain with COVID. This contractor wanted to keep his crew working. They showed up and it was 0 degrees. So it was actually 0 degrees to do this work. And I said, are you sure you want to be working on this project? But they did. I don't know if I could get a dedicated crew like this, like I did, for them to do this today, but I had them all to myself for a couple weeks there to tackle this part of the project. So this is just showing some images of them rebuilding out those window boxes after they took off the siding and prior to putting up the zip panel. The photo on the right is just a photo once the zip panel was installed, just a photo of them properly sealing all of the seams. And I mentioned air sealing, and the contractor didn't understand why we needed to tape around the openings, the windows and doors. There's actually a lot of back and forth, and ultimately we did have them end up taping, but again, there's these little arguments or differences of opinion that happen on the job site when it comes to proper air sealing, and this was one that, I mean, it wasn't a huge fight, but it was, again, they were pushing back, like, why? I don't understand why we need to do this. So just another example.
Yeah, the whole benefit of the zip system is that it's a system, and that
Oh, we lost Chris.
Yeah, Chris, you cut out. I
Hey,
thought that was,
sorry. The
Okay.
whole point of the zip system is that it's a system. It's not just a green board that does magic stuff. You have to use that sealing tape to connect into any penetrations in that sheathing. So where it connects down to the foundation or connects around windows and doors, it has to be connected using tape or some type of caulk sealing product. And so what Kendall's describing is she bought a not inexpensive product, and the product is great, but just like anything, it has to be installed properly. And she had to be very mindful of that throughout the process. And she had both myself as well as other people involved helping to advise her to make sure that she was getting the best value out of her installing contractors.
yeah. I mean, and one other thing with the zip panel that I'm recalling, which may or may not be important, but after attending a building enclosure symposium recently, more on commercial buildings, but the contractor that I worked with did not want to use the screws or the nails that were specified by the zip manufacturer that were sent with the product. They wanted to use their own, probably for ease of installation, or I don't know, but they ended up using their own. They didn't use what was specified. So there were little arguments along the way, trying to figure out, what's the most critical thing here that I'm gonna fight about. So yeah, had to pay really close attention to every little thing going on. And they were great. They did a beautiful, the zip panel and the windows, they did a beautiful job. And I'm really fortunate that Nick connected me with that crew. But before the zip panel went on, so one thing I wanted to do with the project was preserve the plaster walls inside. They were in good condition, and I sometimes don't know if when we look at these old homes in Detroit, these vacant homes, do they require a full gut? If I were to do a project like this again, I probably would, maybe, I don't know, want to open up the perimeter interior walls for ease of insulation install. But on my project, knowing that there was no insulation in the walls, we primarily did a drill and fill from the exterior before the zip panel was in. So Chris mentioned it's the dense pack cellulose that the contractor blew in the insulation.
Hey, Kendall, I got a question in the chat from Chelsea, who asks, Chris, can you touch on the decision to remove the basement windows and if you have any alternate solutions?
Basically windows are losers. Windows waste energy. So having less windows is a strategy for improving building efficiency. So not every house will need that necessarily. Again, under different circumstances, maybe we wouldn't have had to take that measure, but it was, I think also for Kendall, it was just one of those things where, security for this project, it was something she didn't mind necessarily taking on. The basement is not living space. So it does not really need a lot of light or ventilation down in the basement anyhow. So, there were other reasons beyond energy that were part of it, but basically, the big issue is that you can insulate basement walls so that they are relatively high efficiency in terms of insulation levels. Windows, even the best windows, are not as good as a well insulated wall system. So
yeah, and I had 6 large window openings and a coal chute, so I had a lot of openings in the basement. So that's why, and yeah, security and wanting to down the road insulate the interior of the basement foundation wall. But I just noticed the time, so I'm going to try to keep things moving along here. But I talked about drill and fill from the exterior. We did do a little bit of net and blow where the walls were open, and then a few areas where they had to do drill and fill from the interior. Of course, there's always challenges with insulation. In this image, you can see where there's gaps in this dense pack cellulose. And then also making sure sure that the ventilation was, everything was ventilated properly. So I did a full attic clean out of the old, very inadequate, dirty existing insulation. And I'm glad I did, because I got up there and kind of saw where, how the house was supposed to be properly ventilated. And I just felt more comfortable kind of seeing it myself and working with the contractor on the best solution. So we keep talking about air sealing, and Chris and Nick emphasize that a lot with me, and I emphasize it a lot with the contractors. I had to do a couple tries to make sure the attic was properly air sealed before blowing in the insulation. So even after hiring an insulation contractor to do the attic air sealing, it was when Chris came in and did the preliminary blower door test that we realized there's a huge draft of air being sucked down from the attic. So there's a huge gap somewhere. So just making sure you feel like the insulation contractor is doing the proper attic air sealing before even blowing in that insulation, and the blower
Yeah, and
door test.
I'll just say, it's not even necessarily like, it's always easy to go, well, the contractor wasn't being careful. It's not even always necessarily that simple. Existing homes are just tricky.
Yeah,
Again, these were not built to be airtight originally, and the types of gaps and penetrations and chases and things like that you have that end up leaking air are not always easy to be seen. And sometimes, when they use the air sealing products like spray foam, like what we saw, sometimes those products, they may have issues of chemical mixing or adhering to the substrate properly. It has to be blown in at, an ideal temperature condition. And so, this type of air sealing process was necessary. This home had lots of big holes, lots of big chases and gaps that we had to seal with, a contractor using a spray foam rig, even though we were going to do aero barrier. But, it just goes to show you, a few slides back, Kendall had shown before the aero barrier process started, the blower door was at 6 point something air changes per hour. Well, that was after the contractor had done all this sealing. So that was after zip system. That was after doing spray foaming of certain things. So, aero barrier was able to take it the next step, but it just goes to show you how challenging it is in existing homes. When I got my home from 1927, it was over 15 air changes per hour. And I've gotten it down to about 7 now, but there's still a lot of room for improvement still with my existing home. And this is an experienced energy efficiency professional trying to do the right thing, so it's not just always about the contractor didn't do it well enough, but these are things we have to be mindful of. And this is why building in like a mid-construction blower door and infrared scan can be a very valuable choice.
Yeah, thank you for that. I went through some of the attic insulation or air sealing photos, but I wanted to touch on the basement rim joist as well. So I had to knock out brick between these floor joists, if you can see in the photo on the left. And then on the photo on the right, it's a little hard to see where I had started to pull the brick out on that wall. But I need properly vacuum and clean up those areas prior to the closed cell foam insulation. And like Chris was saying, with some of these products, so this was applied right on the cusp of a maybe too cold of a day where there's no heat in the house yet, and the weather was not cooperating, or the time of year in which we were trying to do this. And so this contractor, again, this is not the fault of the contractor. He knew that it might be a little risky because of the temperatures shifting at this time of year. But this is where the product, because of the cold, did not properly adhere, and you could see these little gaps. So he came back and addressed those. I'm having some more issues with images, but these are, just basement windows, and just decided to brick those up for energy efficiency and security reasons. This was the hardy board siding being installed that wrap that they put on the house probably wasn't necessary with the zip panel system, but it also wasn't harming anything, and it's something that they do with all of their siding projects. So that was the crew out there. The mini split heat pump, these were ductless systems that were installed on the inside of the wall cavity. You can see the indoor unit on the wall. That's not the final installation. It looks a little crooked there, but you can just see an example of what the system looks like, and on the exterior of the home, the outdoor units and how they were placed. So because this is considered 2 units, two family, there were 2 separate systems. This is when Chris came in and did the preliminary blower door test, and he did an infrared analysis. So he was looking for identifying air leakage and thermal bridging to point out any areas that I should address either myself or have one of the contractors address. He put together a report. I guess I'm not going to go through all of this unless there was anything that you wanted to highlight, Chris, but he put together a report for me that identified
Yeah, I mean, the big
few of
thing
the
is that,
issue areas.
the big thing is that, again, Kendall had already paid an installation contractor to come in and insulate the building and do some air sealing. But even after they had done their scope of work, there was still, some issues. There were some spots where insulation was kind of not installed properly. Not everything was sealed properly. And we were able to see that using the combination of a blower door test, which depressurizes the building, and then infrared cameras, which can help basically identify hot and cold spots. And so, had it not been for these diagnostics, then, Kendall would have had less to be able to hold her contractor responsible for fixing any of these defects.
Thanks, Chris. Yeah, some of the photos are not appearing on these slides for some reason, but we're getting close to time. We have 6 minutes left. I'm available to stay on longer to finish the slides for anyone who wants to. And I want Nick to be able to share about the aero barrier product, but wow. And these images are not, we're having some trouble with these.
I can see him, Kendall.
Oh, you can? Oh,
I did for, well, some of them.
can you see that?
No, I can't see that one.
Yeah, for some reason they're not loading properly. So maybe I'll just turn it over to you with your slides since my images aren't loading for some reason.
Looks like all of ours aren't loading either. But my brother-in-law, Brian, and I do aero barrier here in Michigan. And it's a great application for new homes, but also any home that's going through a heavy remodel or a home that's maybe even just changing hands. I don't know if you want to go to our next slide there, Kendall. I can see 62 right there. Slide number 60. Actually, if you want to go to 61 or 60.
Okay, I was on mute. Can you see the slide?
I can see slide number 60, 61. Go back a slide though, if you can. Yeah, so when, oh, I think
Can you see it okay?
Yeah, we can see them all.
Okay, so I reloaded the slides, whether the images weren't showing. So I will, yeah, there's your slides.
Okay, perfect. All right, so, this has kind of been hammered home quite a bit, but benefits of reducing air leakage, you're going to see some cost savings. You're going to have a more comfortable home. When you reduce the air coming to the home, you also reduce the moisture that's coming to the home and more moisture that may be getting trapped in that wall system. Chris also highlighted on this, but when you block the air, you can also block some of the noise. You can block some of the bugs from coming in, and you can improve your indoor air quality. So if you want to go to the next slide. Our service, we apply a fog applied caulk. Well, we use that same blower door that Chris uses to depressurize the home. We pressurize the home so that fog tries to leak out of that house, and it finds all the gaps and cracks in the building. That's why it's great to be done during a construction project. So that way we don't have to worry about finished flooring and things like that. It does not stick to any of the walls. It gets driven deep into the penetrations of the building. Some will settle to the ground, and that's why it's best to be done before finished flooring. But we call it a foolproof way to air seal because we don't tell the fog where to go. Pressure does. That big blower door is putting 100 pascals of pressure on that building, and the fog will find the leaks. We're able to sit back and watch it on our computer as it gets tighter and tighter and tighter. And we're able to shut it off when we get to our goal, or if we end up hitting like a flat line. It does have limitations. The limitations is it won't seal anything greater than 1/2 inch, which is really great that Kendall took all the steps that she took prior to get to where she was. Because, she put on the new sheathing and covered up all the enormous gaps that you could see when her siding was off. She did a lot of that air sealing in the attic and in the basement and made those differences. So that way we could come in and our fog could find all the little gaps and cracks that you can't see. Now, if you want to go to the next slide. These are just some more thermal camera views. Chris had some. These are some other projects. It just kind of shows where cold spots are, and cold usually indicates that there's some air leaks going on in that area. If you want to go to the next slide. So the first thing we do is we cover everything in the home that we don't want to seal. We tape your windows shut. We put some tarps down on the ground. We block off all your HVAC ducts. So that's step one. And then if you want to go then, and we also cover your bathroom vents and your drains and things like that. Step two is we turn that fan on, we build up the pressure inside the house, and we start fogging it. So the fog will just start leaking out, and we just continually watch it on our monitor. If you want to go to the next slide. So these are just some images of what it looks like. Some of the sprayer heads, a foggy building. We're able to sit back and watch it on our computer. Want to go to the next slide. So Kendall's report, very similar to this. It kind of shows a starting point. And if you want to go back to your report for a second, Kendall. So, when we arrived that day, it's 6.1 air changes per hour, which was the equivalent of a 271-inch square hole. When we left, looks like we sealed for about 4 hours. And the little jumps and things in the graph, a lot of that comes from when we open the door to run in and move our heads around and things like that. But it made progress over 4 hours. So 4 hours later, that hole had been essentially reduced to about a 10 by 10 square inch hole. So essentially 100 square inches spread out over the course of this entire, 2-story home, multifamily home is pretty darn good. So it's 2.26 air changes per hour. Let's see, I don't know what other slides we had, but here's some more pictures on the bottom. It does seal around a lot of electrical penetrations coming through walls that head to your lights. Behind your light switches, it does a lot of bottom plates, top plates, can lights around your HVAC penetrations. The sealant is Green Guard Gold certified, so it has no off-gassing, ultra low, VOC content. It was tested to withstand a 50-year freeze thaw cycle. It's something that we can easily apply and measure while we're doing it. So we know that we're making a difference, and we know when we've kind of reached our point where we can't do any more. So, but it's a great application for older homes that are going through a remodel, and we're happy to help anyone in the city of Detroit or throughout the state.
Thanks, Nick. I did want to
Thank
just
you.
acknowledge that it is 12:30. I'm able to stay on to finish the slides. If others need to go, please hop off. I'm just going to go back to those aero barrier slides very briefly because the images weren't loading. But this is kind of what the setup looked like at my house when Nick and Brian came out and set up the blower door test, set up their computer. This is just showing the tripods set up throughout the house. And then Nick already went through the results. So, but we're almost to the end. I just wanted to touch on the last few elements of the house. So we talked about the ventilation system. So because this is 2 units, the city does require 2 separate ventilation systems. So each unit has its own whole home ventilation system. This is what it looks like in the basement. So the air that's being exhausted from the house is exiting from a vent out of the basement foundation wall. The fresh air being brought into the house is coming in from a vent from the attic, which you can see where the ductwork exits out of the house here in the attic photo. This is what it looked like in the basement prior to installing the system. They were getting the vent installed. And this is, it's hard to see in the photo on the left, but you can see the 2 vents that were placed on the north side of the house. The air exhausting from the house is at the lower level. We didn't want to bring in fresh air from the lower level in case the neighbor had a car parked in the driveway or somebody was standing outside smoking. So we put it up high on the north side of the house. And then you can see the vent that comes out the basement here on the right. And this is just another image showing the vent. One issue that I'm dealing with that we did not catch, the city inspector did not catch this either when I had the rough inspection, is that when the contractor brings in the fresh air from outside, they bring it in through an insulated duct in the attic, but when they bring it down into the house, they used a metal duct. So when I had my city inspection, my contractor said, let it run overnight. So it will, you know, when the inspector comes, it will have been at least running for 12 to 24 hours. I got there with the city inspector and there was a small puddle of water on the basement floor from condensation. So I looked back at the install instructions, and the only place where it mentioned anything about insulated duct was in this image on the left. So it was just a small error that would cause a major headache if it wasn't addressed. So we're in process of addressing it. I had to reopen the walls, but as you can see, there's not a whole lot of space in there. So that's where the chimney previously ran. So we are addressing that right now. We talked about heat pump water heaters. I'm not going to say much more. One thing Ben and I have often talked about with some of the flooding issues in Detroit is making sure that appliances are raised off of the ground. So I think we're starting to see more and more contractors that are doing that. And then the fun stuff is some of the interior finishes. So the home is almost ready for occupants to move in. There's still some finishing touches, but the hardwood floors, the original hardwood floors cleaned up beautifully. This is a image of the downstairs kitchen and the mock-up, but the actual and the mock-up with the appliances shown, and the upstairs kitchen as well. So almost complete, almost ready for occupants. The home is incredibly comfortable. Every time I'm over there working, I'm thinking it's more comfortable than my own home. Just this consistent temperature and very comfortable home. I don't know what else to say, but that is it. Wanted to thank everybody. I'm able to stay on for questions. I don't know if everybody else is, but if there were any questions now or in the chat, either myself or Chris or Nick can help answer them.
Hi, Kenzo. I have 2 questions. The first is, and I may have missed this earlier. Do you mind sharing like a
Hey,
small-
Dominique, I'm sorry to interrupt you. It's hard to hear you with the background noise.
Oh, because I'm in the coffee shop.
That's a little bit better, unless you want to put your question in the chat too.
I'll just put it in the chat. That'll be it.
Sorry, I just wanted to make sure I heard it. Were there any other questions from anyone?
I'm sorry, kind of like stepped away for a minute. Did you answer the solar question?
Well, I put solar or the idea of any renewable energy to the very end of the project. Also, this is a personal endeavor with personal finances. So trying to figure out how to fund and what to prioritize. So the goal is to ultimately install solar panels. The timeline for doing that uncertain at this moment. I mean, I think I don't know what types of incentives, if any, exist for landlords, property owners to do these types of projects or to even install solar. But that is the challenge for seeing more rental properties that are renovated to these higher standards. You're on mute, Bob.
I'm going to send you some information about the IRA, which I think will be enlightening. From what I understand, you might be able to get up to a 70% credit against the cost of solar. I don't know whether an investment tax credit makes sense to you in your personal situation, but yeah, the IRA is a game changer for solar, especially in this zip code.
Yeah, thank you, Bob. Yeah. Were there any other questions?
Dominique's question in the chat is, would you mind sharing a range of what these renovations cost?
Yeah, so that is a tough one because there were questions about that when we presented in September. Some of the improvements, the major improvements were done prior to 2020. And so those, like the heat pump system and the roof. And I've checked in with those contractors and they've told me that if I installed that same system today, it would be double the cost. I looked back at even my windows. I think it's like a 60% increase from when I purchased them. So it's really challenging for me to figure out what the cost would look like today because we've seen such a change in pricing. I do know going into this project that most folks who were pursuing a home renovation like this that was two family agreed that you're looking at least $175,000 renovation because it's two families. So there's two of everything, two kitchens, two double. But yeah, I can't give I just know that a lot of the things that I did install have since doubled in price.
And that's not relative to just them. Well, that is relative to everything. Then many things have doubled or gone up by high factors. Would you just to clarify? Okay.
Yeah, right. Not these specific like systems per se. Yeah. Even my windows, which are Home Depot purchased windows, have increased 60% since the time I purchased them.
Well, Kendall, I also think the other thing to keep in mind too is that a lot of the things that you had to do to this project, you're going to have to spend the money on it to renovate it, even if you didn't think about energy efficiency at all.
Yeah.
You were going to need new heating and cooling and water heating systems, lighting, appliances, interior finishes, kitchens, baths, etc. So certainly there was some additional expense when it came to things like insulation and choosing specific products for all those categories previously listed. But it's important to understand when you do a deep retrofit like this, you were starting almost from like a shell, and you had to kind of start brand new. So so sometimes we're really talking more about incremental costs rather than the actual hard cost.
Yeah, thank you.
Super important point, Chris. Thanks. I was going to say incremental costs. So yeah, right there with you. And I think that's I think that's something that we need to be talking about more as an industry in general, and saying, well, it's 5% more than a regular gut rehab, or let's say a gut rehab to code. and then monetizing that and saying, well, what does 5% cost? And then saying, well, actually, given how efficient this house is going to be, that payback is 5 years on, what is effectively a 50-year investment of this whole overall renovation or whatever those numbers work out to be. So yeah, thanks for the thoughts.
Yeah, and I know, I don't know if, Jenny's still on the call. ICF was very helpful in this project as well, managing this pilot for DTE. Some of you may recall that we were, ICF invited the EWR committee members to Kalamazoo a couple months ago to see some of the homes, the all-electric homes being built through the Consumers Energy pilot. And one thing is that I believe I'm accurate in saying this, that most, all of the homes, I think in the Consumers pilot and all of the homes but 2 in the DTE pilot were new builds. It is a challenge. Thanks, Jenny. It is a challenge doing a project like this with the existing homes, but we have a lot of homes in the city to renovate at the same time. So trying to figure out how to do it, I think is really important. We can't build all new, brand new homes throughout the city. So, and the 2 existing homes are in Detroit, which is great. All right. I didn't have anything else. It doesn't sound like there's any other questions.
Yeah, that was great. Thank you, Kendall. That was it's an incredible project, and Chris and the team from Aero Barrier as well. Yeah, with that, I will say happy holidays to everybody. And thanks for joining us this year. We had a lot of really great meetings. Just as a reminder, we will be off for the first quarter of the year. But feel free to email Kendall or I, and we look forward to seeing you again in the spring.
Yeah, thanks everyone.
Just a quick shout out to everybody.
Happy holidays.
Thank
Happy
you.
holidays. The Lean and Green holiday party is tonight. Our PACE administrator at what's the Masonic Temple, 5 to 7. If anyone wants to go, you can still probably reply.
Thanks,
Thanks,
Bob.
Bob.